Welcome, everyone. Hello. I'm happy to start this afternoon session. I give my warmest welcome to all of you who are here today and strong after lunch decided to join this session about data centers, digital twins, and AI for sustainability. We set up this session as a discussion forum, as we called it, so like inspiring ourselves to the Latin conception of this term. So we wanted to bring together not only researchers, but also technology providers, industry stakeholders, and policymakers to explore how data centers, digital twins, and artificial intelligence can accelerate sustainability in the built environment. And we want to do this through dialogue, through conversation and discussion with these different stakeholders and experts. We talked a lot about this morning about the smart readiness indicators, and of course, data centers are in part also what will enable the smart readiness indicators to be applied and to be utilized. We know that the European Union is all in favor of this so-called green and digital transition. But I guess maybe the term of sustainability applied and paired with the term data center doesn't really ring a bell, let's say. It sounds a bit counterintuitive. So what we want to do is, with this panel, try to challenge this common sense and dig deeper into this aspect and explore these new viewpoints and perspectives that can help us understand how actually data centers can also become a source and an opportunity for increasing the sustainability of our territories and the built environment. I'm talking in plural. I say we because we are here, and I was also invited to moderate this session by R2M. So I'm, first of all, I would like to thank Alessandro Lodigiani, Roberta Roffi, and Thomas Messervy from R2M for inviting me in a representation of the Italian Proptech Network to support and co-organize, of course, this event. To give you a little bit of context, the Italian Proptech Network has been supporting startups and scale-ups that deal with digital technologies applied in the real estate sector and in the built environment more in general since 2018. And we try to help these startups meet the demand from well-established real estate players that need to integrate these digital tools in order to reach their objectives. We want to study, of course, the impact of digitalization and its potential in transforming the traditional real estate mechanisms and processes and interactions among the real estate stakeholders and players. And how does this happen? Of course, by capturing, storing, and elaborating data. And this happens, of course, into data centers. I am Chiara Tagliaro, and I will be your host here today. I am a researcher, and I am an assistant professor at Politecnico di Milano, and together with Andrea Ciaramella and Stefano Bellintani, I am one of the scientific coordinators of the Italian Proptech Network. So let's kickstart this afternoon. I'm very happy to start introducing our guests. The afternoon will be long and full of interesting talks. While I welcome Marco Leone from Nomisma to join us on stage, we'll have also a virtual connection with Giulia Pastorella, member of the Chamber of Deputies and a city councillor in Milan, and Marco Leone instead represents Nomisma here today. Welcome, Marco. So just to give a little bit of a background before leaving you the stage, according to the last PwC Emerging Trends in Europe survey, there is a growing demand for technology and infrastructure in energy production and storage. And of course, this is also pushing the market of data centers. New energy infrastructures and data centers are at the top of the rankings. They appear for several years in a row on the top 5 real estate asset classes that are expected to collect the interest and the investments from international investors. So clearly, there is a strong interest for all of us, also for our economy, to develop these assets and to then attract also international players. There's a huge debate about the impact of all this. So from an economic point of view, but also from an environmental and a social point of view. And this is exactly what Marco will help us understand today with the help of Giulia Pastorella. So Marco, please. Thank
you. Good afternoon to everybody. I will give you some very few words about a sort of introduction on how data center impact territories, and then I will leave the floor to Giulia Pastorella to go deep in detail in this topic. It's clear that is highly strategic for local communities, not just for the country, but in general for local communities. It is clear that there is a huge economic and social impact. The problem or the question is how to measure it, how to go in deep detail about that in the starting period, in this period in which the new projects all over Italy need to be developed. Again, there is a common sense in these slides, but it's useful to introduce the issue that the data center need to be approached with a different point of view. We have personally, I also have a specific real estate and financial point of view, but we have also to understand that there are very important sustainability matters. We are here to understand what we can do to get sustainability in the data center area. And then after having created the conditions to build and to manage data center, you have also the need to take into consideration an important reporting and the stakeholder engagement for local territories is absolutely necessary. I work with Nomisma, and Nomisma has deep knowledge in the stakeholder engagement in different fields, in different areas and scenario. And we were strongly committed, and we were on a specific project where, for example, logistics had a very huge impact on local territory. And now also in other side of the market, there is a change from logistic to data center, because in sometimes for the local territories is even better to go on in this new sector. I will leave you the floor and the slides for details, but here I just underline the huge amount of investment. You may know that in data center are very, very costly, even 10 times more a logistic project probably. There is the problem of energy and connectivity, which is the key question. I will be very interested to understand why all the people are coming to Milan and very few in other side of the territory. I think it's very important to understand these dynamics. The change of urban environment that has to be managed when a big, huge data center arrives, you have to think about that. Obviously, there is also an employment factor that need to be measured both in the direct employment that can be created, but also indirect employment. And then again, social, environmental, and real estate market can be very impacted positively, I would say, by a new project of data center. Again, this was common sense, was just to put on the floor some key considerations, but now I'm very proud and happy to introduce to you Onorevole Giulia Pastorella. Onorevole in English? I will get the deputy. Giulia Pastorella, that is not just a deputy, but is a woman that has done management in the digital industry for years, so is very experienced in this sector, and is also the first sponsor of a bill that has introduced in the Italian Parliament the need to write a specific legislation, a specific bill to help the development of the data center. Giulia, I hope that you can hear me. And
Yes.
okay. I would like to ask to Giulia some key questions. Then we have a short time frame, so we have now 10 minutes. I would begin asking you, Giulia, what's the reason why of the new bill for which you are the first deputy that has signed the request of bill?
Yeah, well, first of all, thank you very much for the invitation and for Marco for this session. It's funny, in Italy, we have laws for everything. As a liberal, I tend to abhor the idea that you need a law for anything. However, in this specific case, data centers were really the Cinderella of digital transition in the sense that they didn't exist in the normative landscape in Italy. There's no indication as to how they should be treated in terms of taxes, in terms of urban planning, in terms of lots of aspects that were really missing. So in this sense, the law that I'm trying to introduce, because it's still ongoing, the process in Parliament, really tries to streamline, accelerate, make it easier for these investments to come to our country and for these key infrastructures to really be more spread, as Marco was rightly saying, across our country, and not to be wholly concentrated in Milan, because there you found some local communities, some mayors who were really kind of forward thinking and understood that it was good to have these infrastructures, but clearly those infrastructures would benefit the rest of the country as well and be key for the development of other areas as well. So in a nutshell, the need for a law was paradoxically to make it easier for Italy to digitize and to have these kind of infrastructures, especially as we talk about AI and all sorts of things that can be done thanks to this computing power in data centers.
Thank you, Giulia. Again, in Italy, there is a complexity of legislation. We know that there is a national level of legislation, and then we say that in any country, in any region, in any municipality you go, you find slightly different rules. So what about the so-called public governance? So the state level and the regional and local level. What do you think about the possibility to work also on this issue, if you think is an issue?
Definitely, you've forgotten the European level as well, because so far we mainly have guidelines and reporting obligations, and then of course some key specific areas of legislation on energy. But generally speaking, you have no specific legislation in Europe. And the idea to have an Italian legislation was precisely to prevent each individual region or even municipality to go their own way and to create a patchwork of rules that would then prevent investments or at least disencourage some investments. The problem is that democracy takes a long time. So as we are working on the law, in the meantime, some regions, not only in the north, in Lombardy, where of course it makes sense because that's where you have most of the data centers, but also elsewhere, are rushing forward with some guidelines, legislation, etc., because they feel that there's a vacuum, that there's something missing, and they want to jump on the opportunity of these investments. So I think it's key to ideally not to have overlaps and not to have different levels legislating at the same time. But if that is anyway the case and you have different levels legislating, that at least they are coherent and not in opposition, so that it makes sense for both the local communities and the investors to navigate the normative landscape. It shouldn't be a hindrance. That's the issue. And given the title of our session, it shouldn't be a hindrance, but it should stick and have clear rules on some aspects. And the sustainability aspect is one that in our law proposal is very much core and center, because of course we all want those billions coming to our country, but not at any cost. So for instance, we say that you should aim at using brownfields, that you should as much as possible use clean energy, be it renewable, or I personally would be in favor of reintroducing nuclear power in Italy, but we're not there yet. So we really, pay attention to the kind of use of water. So all of the sustainability, both in the environmental sense, but also in the social sense. So again, trying to say to these investors and these data centers, you are part of a local community, you will be part of a local community. You should really integrate and make a positive impact with your, not just with your occupation and the jobs that you will produce, but also, by helping the community to build, I don't know, cycling paths or whatever. We don't go into details in the law, but I've seen many, many investors voluntarily help the communities with little projects because it's a way to give back and to integrate.
Thank you. A very, very useful and interesting insight on the sustainability and the digital transition. But we have also a sort of question mark, a risk to and the need to be competitive with other countries, because if we are not we not speed up this process, we feel that we have a great competition from other countries where data center can be based with simple rules, and there is a potential issue on the digital sovereignty. What is your view on that? Do you think is a key element, and the international competition can or should give us a pressure to speed up this process or not?
Well, definitely. You mentioned the word speed many times, and indeed, the length of the process, the authorization process, is one, again, of the core aspects that we try and address in our law because we're not competitive. In Italy, on average, it takes 5 to 6 years to build a data center, which is clearly not, comparable to Spain or obviously Ireland and Germany and other countries. So, of course, we need to be competitive vis-a-vis our European partners, but also, as you rightly mentioned, this government in particular, even though I'm in the opposition, I do share the view that, sovereignty, I see it more at a European level, but also national level is key. And having the capability to host and process data on the national territory is one of the ways in which some people see digital sovereignty. I personally think that data is secure as long as you have the right standards, protocols, certifications. So it's not necessarily a matter of geography and location, but there's an aspect to it that I can understand. And finally, what the question that we are asking as we are dealing with this law, processing this law, is will there be demand for data centers? Because of course we can make the process easier, but if there's no demand by the local SMEs, the local industries, the local services, etc., then data centers won't happen out of nowhere. We don't have to incentivize, as we call them, cathedrals in the desert, meaning, palaces that are then empty. So we need to make sure that we also, in parallel, make European and Italian in particular industries and especially SMEs understand the benefit of using the services that data centers provide for their innovation, for their competitiveness, for their productivity. And I think the two go in parallel. It doesn't make sense to build infrastructures if the market doesn't understand or doesn't use those infrastructures. So that's also another aspect that we're working on the digital culture, digital understanding, making sure that our productive system understands what benefits would come from using AI, from using certain software, and all the rest of it. Otherwise, it's pointless. Of course, you can have data centers being located far from the demand, because in some instances, like in some of the applications using AI, latency is not an issue. But equally, I think they should be servicing also the local market and the local industry. So having this industry understand the benefits is, should go in parallel with regulating the infrastructures themselves.
Very, very interesting. You have probably already touched the main point of what can do the public sector and what could do the private sector. But the final question is not just in the data centers industry, but in general in Italy, we are often speaking about public-private partnership. What is, under your opinion, a path and a model that can work in the digital industry and in the data center development about public and private partnerships?
Well, in this particular case, I'm not sure I would talk about public-private partnerships. I would more talk about the public playing a enabling role for the private sector to come and invest, because at the moment, the rules, or rather the lack of rules, is becoming a hindrance, is becoming an obstacle to private investments. Of course, there are some ways in which the public could help. For instance, if they have land that is not being used, or that is the property of the state that could be given or sold to these players, of course, that would make sense. You have the entire public administration who would also benefit from using some of these infrastructures, provided that they match certain standards, etc. But generally speaking, in this particular case, even though I'm a big fan of public-private partnerships, I think we should more talk about the public should do its job, which is to make the private sector have the right conditions to fully utilize its potential, and at the same time, stepping back as much as possible when not needed. So I'm against giving incentives and fiscal incentives and this and that. This drugs the market and risks, creating a bubble where lots of people think they invest in data centers, but actually they will never see the light, or they will never see clients coming and putting those racks and those servers in those empty boxes. So we have to be careful about not boosting or spoiling, as it were, the demand and supply reasoning as the public sector, but we should definitely be an enabler and accompanying in the digital transition as much as we can.
Very much, Giulia. Applauso per Giulia. I think it's not so common to find Italian young and smart deputy like Giulia. I think we should need more like you, the Deputy of the Italian Republic and Vice President of Azione. Now, Chiara, I hope that we were able to give a short introduction for the rest of the debate. So I leave you the floor. Thank you.
Thank you.
Thank you so much. Thanks also to Giulia Pastorella. Wow, that was a very, very good introduction. Helping us reflect on the function of data centers in the public interest. What are data centers? Data centers are very complex systems. On the one hand, they are real estate assets, of course. They are also technology. They are also infrastructure. There are many different things. Yes, we mentioned also in the speech now that data centers sometimes come exactly out of the transition from logistics. So basically, just as the rise of e-commerce in the past decade boosted the demand for logistics space, today the adoption of, for instance, generative AI and of course other tools is driving this sector, the sector of data centers. That until a few years ago, of course, it was almost unknown or definitely underdeveloped. And now it's becoming one of the most promising asset classes to invest in. So this new roundtable, I'm inviting here Luca Dozio from the Data Center Observatory of Politecnico di Milano, Gianluca Metti, RICS and Starching Maestrale, and Mattia Mariani from the Italian Data Center Association in Dearns to address the first roundtable here. And we want now to provide some market and process perspectives to understand how different stakeholders that we mentioned also in the speech earlier with Marco and Giulia, how they can support the sustainable growth of the sector throughout the entire data center life cycle. So please, Luca, here's your turn. Thank you.
Hi, good afternoon to everyone, and thank you for having me here. I work in the Data Center Observatory, that is one of the is a research group in the Department of Management Engineering. Okay, thank you. We analyzed the data center market for the last 5 years because this is a research that starts from another observatory, that is the Cloud Transformation Observatory that analyzed the cloud market in Italy and in Europe for the last 17 years. In 2020, we noticed that there was a lack of data about data centers, so we decided to start this research. And we collect all the data that I'm going to share with you directly from the data center provider, collocator provider, or cloud provider. So all the players that give some sort of service connected to data center. So to start, I want to share this slide with you that can give you also an idea of how many data centers and how they are distributed in our country, because on the left side of the slide you can find the map of Italy with different shades of color that can give you an idea of the distribution. And of course you can already notice that we have a lot of data center here in Lombardy, but in the Milan area in general. This is the most interesting, the most important area in Italy for data center. We have also a second important area that is developing, that is the Rome area. But this is a very common situation also in other European countries, because usually the developing of data center is concentrated in one area and maybe a second main area. So just to give you an idea of how many players we have in Italy, we collect 65 players that operate in Italy. And if you look the same data from 4 or 5 years ago, we had just 55 players. So in just 4 or 5 years, 10 new companies decide to invest in our country. And to give you an idea of the increase of the market, we usually collect data also connected to the power capacity, because it could give you an idea of how many data centers and how complicated they are. We have an increase of about 70% just in 1 year, so from 440 megawatts to more than 500 just in 1 year. And also we try to make some forecast just to have an idea of what we could expect in a couple of years, because we don't really believe in very long-term forecasts, so we just decided to have a time frame of 2 years, and we expect to arrive also to more than 900 megawatts just in 2 years, because at the end of 26, of course, there are a lot of variables that come into place, because regulation and the market dynamic will have an impact. But this can give you an idea of how fast is growing this market in Italy. And also from the number of players, you can see that we expect to arrive to 74 players, so another 9 new companies that want to invest in our country. But if you are not really in the data center market, maybe this chart can give you a better understanding of why there is so much interest about data center. We make an evaluation. We think that just in 23 and 24, 5 billion euro were invested in Italy for the development of data center, and we expect another 10 billion euro just in the next 2 years, so 25 and 26. Of course, there are a lot of drivers that will speed this process, because we have the expansion of national operators that decided to invest more in our country, but we have also a lot of plans from international cloud providers, and of course all the AI market, because the growing of the AI market of course require more computing capacity, and so more data center. And also our country is in a very good position for the developing of the connectivity. because we are a very good place for all the submarine cables. So another data center, another variable that can facilitate the development of data center. And then, of course, the attention of institution that can speed up all the process. And just to better understanding why so much interest in the city of Milan and why we could have a role not just for the Italian market, but for the European market. In Lombardy, we estimate that we collected from 8 to 12 billion euro in the 4 years, so 23 to 26, and now we have about 47% of all the data center in Italy. And we expect to double the amount of data center just in 2 years, because at the end of 26, we expect to arrive to 480 megawatt installed. And of course, as I said, it's a very good moment for the developing of the market and to play an important role, not just for Italy, but for European market in general, because the European market usually is was developed in 5 most important market, the FLAPD markets, but in the last couple of years, they have a slowdown in the developing of investments. So this situation create an opportunity for all the Nordics country, this also for the climate condition, because of course it's easier to manage with the temperature issues connected to data center, but also for all the South Europe markets, so Spain, but of course also Italy. So it's very important to create a good environment for the investments, because we could have a role as one of the most important computing center, not just for our country, but for all the European market. So I think I can give you a little overview of this market. I hope it was interesting.
Fantastic. Thank you so much for this introduction about the market, definitely necessary as a context. So let's move on with Gianluca Metti, who will tell us about why data centers are not an evolution of logistics, as we said before.
Thank you very much for your coming. Only try to introduce myself. I am Gianluca Metti. I am a certified project manager by RICS, and also I cover the role of senior project manager in Starking and Maestrale, who are 2 engineering firms that develop engineering services in the data center field. What I try only to describe now in the next 10 minutes is in which way an engineering firm can support the client and the investor in the growth, and also try to show the methodologies that we need to apply in order to ensure the quality of the buildings. And it's not easy. The next steps is also to try to turn complexity into life. And this is point I hope that I will be able to express properly way. The first thing is what is a DC? DC is an extensive and also an asset with high technology implemented, with high technological performances. Is a high energy intensive machine and requires 2 fundamental requirements. Be protected from external environment and from external forces, and also ensure continuity. That it means 24 hours a day, 7 days. This is one of the point, and the point, most important point in our development growth is the capability. It also is the electricity power available in the plot. So this is the first thing, is to understand if it's a normal development and of the logistic asset. Absolutely not. Is very extensive in terms of square meters, obviously, but the KPI that are to be considered in this market are totally different. It's different also, it's very interesting, the relationship that we need to build among the stakeholders involved in a process of design. There is an investor who put the money on the table. There is an operator that usually has the capability and the technological strengths to define standards to be developed during the design stage. And first of all, the tenant, who is the final client, who design what he needs and what the engineering firm has to deploy. So these things take another point that is very interesting also for RICS members, because as you know, RICS develop ethics in his pathway for the members. And there are a lot of situations that we have to avoid during the design phase. I try to resume that in this slide. And what is important for me is that is the value of the empathy between engineering and the client. It's a long path for the design. As the Deputy Pastorella said before, it takes around 5 years to deploy and to build a data center. And approximately we need 3 years only for permitting. It's very fast, the build, but not so fast, the design and the thoughts. So what is important is to develop a very strong relationship with the client. In any single part of the stage, the most important aim of the project manager is to define in transparent way where are the risks, in which way we intend to mitigate them, and what is that methodology. So if we wanted to go through this conversation, the critical points are, the critical points start from a different system to measure the key factors in a data center that are totally different from logistics. Logistics measure the efficiency on the square meters, and also the value of the asset, of the land, is measured on that. But it's not the same for data center. Data centers have as a fundamental key point how many megawatts can deliver for IT, and the capability for the asset to receive the electricity power. So when you are doing a test fit, but in all the process that you have to follow during the due diligence, the first request is how many megawatts we can deliver in the asset. What is one of the most important key points for efficiency is the PUE. The PUE is a very simple indicator that measure the T-power, the total facility power on the OET equipment power. That it means that if 100% is the need for IT, a PUE of 1.5 means that you need 50% more to ensure the operation of a data center. What are the risks and the critical point? In this slide, I only try to describe, it's only, please try to understand that the days are not obviously a rule, but it's an example. One of the most important points is to solve the environmental authorization. As you know, we have a law that define when we needed to go in VIA or in screening VIA, but this process is very, very long. Actually, in Milano, we have only 2 VIA totally authorized in our city, and they took around 18 months. Obviously, is a big effort that the operator needed to implement, and it's one of the most important risks that we have to face. Obviously, before we have piano attuativo and so on. So I totally agree with the deputy when she talks about the need to reduce the length of this process. It's, in my opinion, very interesting. Take only 2 minutes about the design process and the learning curve that we have during the design phase. Usually for DC field, we use the process. This is a protocol defined by an English institution, and they develop in 7 different stages the RIBA. But what we need only to focus our discussion is on the first 5. What it means that this slide, the first stage is related to the advisory, and usually we take the RIBA till the RIBA 1. At the end of the RIBA 1, we have a test fit that is an exercise that try to fix in a geometrical way the capability of the plot, but it's not already investigated for the next stage. That it means environmental, for example. The critical point is totally on the second stage, where you have to totally complete your survey. You have to be sure that you can go on and you can proceed on the building permit. Then, after the third stage, that usually is our definitive stage in Italian protocol, we can launch the building permit application and also investigate the market with the contractor, not in a tendering definitive way, because we need the stage 4, but we can collect all the offers. This slide can give you an example of the learning curve. I only wanted to put a curiosity to all of you. Usually in Italian, when you talk about the maintenance, is something that we put on on the right side at the end as a weight. It's totally different for DC. The plant replacement strategy is one of the most important report of a total design process, and we need to implement it in the stage 2. If it's not possible to remove something from the plot, as for example, transformer or genset, it's not correct to go on to the project. What's happened after the design phase? The engineering company can be also involved in a QA/QC and design review. Are two different things. Design review is when the client asks to a third party to go deep in the project and try to individuate room for value engineering. And QA/QC is instead a process of quality and control, because usually when you play in other countries, you don't have the clerk of works, but you, for example, in Switzerland is the case, and you need a QA/QC. This is the point that I described to you before about the potential situation of where integrity of the professional is needed, because QA/QC, first of all, design review is not possible to cover by the people who develop the engineering floor. So I am at the end. What is important, only to my end of my speech, is that it's always very important during this long path to build a very transparent conversation with the client, be extremely proactive to anticipate any risk that can suffer his growth. And so project management is one of the key that we need to apply to ensure that. Thank you very much.
Thank you, Gianluca. Thank you so much for showing us. Maybe there were some additional slides here in the deck, but that I think it was a very good also introduction and anticipation for the next speaker and the next topic that we'll address now. You mentioned, of course, argued that data centers are not logistics, but also introduced the idea that there are many different stakeholders that are involved in this long life cycle. So Mattia Mariani now will tell us more about performance indicators, key performance indicators, and the different stakeholders and what interests they bring into data centers.
Good afternoon. For me, the data center market is something that is a topic that I started to work on 10 years ago. And one of the points that I discovered when I started on this topic is that it's different from other asset class. And the question is, which is the key performance indicator that is appropriate for this asset class? I work a lot on the data center, and now I have also the opportunity to join to the Italian Data Center Association in the sustainability group. And I am still understanding a lot about the data center. So starting from the background of the data center is the same as other market. We start, in any case, from the European Green Deal, and I feel that it is similar to the other market. We, as a data center provider, consultant, we have the target of the climate neutrality, the reduction of the emission, and it is the same. But there is something that is different. And looking at the EEG directive, we have some topics that are proper of the data center market. And you see the different topic that I put in the slide. The power usage effectiveness, the PUE, that is well explained by just before. But I put other topic. And the two topics are really, really important because are really key elements and also part of the topic when people say something that data centers are bad or are not sustainable. And the topics are related to the water usage, the renewable energy, and how the data center can be integrated with the city, with the community where they are placed. The directive gives us some points that we have to measure, and it is really, really important for the data center market that this parameter has to be declared and measured every year when the data center is operating. And this means that for the data center market, these key parameters are not only important for their efficiency, but is also important because it is an European regulation that we have to comply. And every year you have to declare. Just to, in the picture, just on the left side, you can see the first report of the data collected by the European Union about the data center. So it's something that you can access from the web, and you can find some interesting results about the data center market. The other topic is that comes from a more local way is the request that we have as consultant of data center or in general in the data center market that comes from the public authority. Because after some initial period where the data center was not really understood by the municipality or the Italian authority, then we have in Italy some also some indication from them. When you present the documentation, for example, the VIA or the AIA documentation, you receive some comments. I don't want to tell you a lot about the process that is not mine. My background is on sustainability, so it's not my preferred solution. Speaking about administrative process, but I take from this process the requirements, and there is something interesting. And if you look, you see that there is the request of integrating green roof, of protect the local fauna, they mitigate the heat island effect, think about the circular economy of the data center. Just to say, data center requires a lot of embodied carbon to be built. You have a lot of MAP system, you have a lot of materials that you have to use to guarantee the adequate level of protection of the data center. The third topic is about the water. And the water is really important because you have you are creating something that is completely not anthropized area. So you have less green area in the data center because you need a lot of space to put the machine, the equipment, for the data center. So it is really important to we have water that fall on the site, and you have to find a way to manage this water. And the last topic is about the impact mitigation. And the impact mitigation for me is also a topic really important because in the past it seems that the data center is a box, and this is the reason for which they are assimilated in the beginning of their life to the logistic, because they are a box. But they are a box that we need, and sometimes we need to have them close to our city. The reason is simple. When you use in our mobile phone the artificial intelligence, you want to have an answer that is very quick. And if you want an answer that is very quick, you need a data center close to you that can give you the network needed for the connection to the mobile phone. So it's really important. If we put closest to the city the data center, we need to integrate with the city. And the integration with the city comes from several points. As an Italian Data Center Association, the sustainability group work a lot on the ESG topics of the data center. And one of the main topics was related to the connection with the community and how the data center can be connected to the community. There is one topic that is really focused not only by the data center provider, but also by the regulation. And the topic is the heat recovery. Data center produce a lot of hot water, and you need this water is waste for the data center. If we are able to recover this heat from the data center, we can use it for the city. And this is the first way that allow us to create a connection between the city and the data center. The second is the integration inside. And the integration means that the data center gives an advantage to the community that live just close to the data center. Taking from something that comes from the regulation, from the VIA process, I can say that is really important that there is a focus from the data center market on the people that live close to the data center, creating an environment that is high quality. So the data center cannot be standalone, but can have to create an area that can be used by the community. And on the second end, I also believe that for the integration for the community, it is important that the data center create a value for the community, is open to the community. Just a question. How many people here in the room visited a data center? Okay. We have not so much people. This is the reality. The data center is a box and is not well known. Why not be open to the community where the data center is built? So the outcome. I want to leave you with this slide with some topics that I can say as the key performance indicator for the data center. The first one is the carbon emission reduction. Carbon emission reduction means that the data center has to improve their efficiency, so use less energy, and then have an offset done by the renewable energy. So the second topic is the renewable energy use. One of the requests, just to tell you something about my personal experience, is to put renewable energy on the top of the data center. But as I hope a lot of you know, on the top of the data center, on the roof, there is a lot of equipment that is needed by the data center to work. So it is impossible to put on the roof the renewable energy. So renewable energy is a really important topic because the data center uses a lot of energy, but you need place where putting this renewable energy. And so having also in this case an integration with the community, with the local outside space from the data center can be really a good point for creating a connection. The energy efficiency, as I said, is still important. From the design point of view, you have to evaluate which is the performance of your data center. But it is more important to verify and to continue improve the efficiency of the data center. The reason is really simple. Data center consume a lot of energy. 1%, 2%, 10% of energy reduction means million of kilowatt hour per year saved. So this is something that is a really big point for the data center market. The other topic that I want to point out is waste management. Waste management is the data center consume and produce a lot of waste during the construction, and we have to work to limit the waste produced during construction. But also the data centers need to be refurbished time by time because technology change. And this is an important topic during the life cycle of the data center. We cannot only focus on the initial phase, but the technology is really quick in the change. So we need to think not only to the initial waste produced, but also during the operation. And finally, the governance. It is really important, the transparency of the supply chain and the organization. And this is very important because you have the need to also say the importance of the data center in our life. And so I think the people, the common people that don't really know the data center, don't know which is the effect and the importance of the data center. So having a communication, having transparency in the data center is really, really important for also for the sustainability of the data center.
Thank you so much. I thank all the speakers of this first panel. I think this was a very nice conclusion, also talking about the social impact and the need for public engagement. If you want to maybe be more comfortable in the audience, you can leave space for the next block. So I'm welcoming here and calling on stage Giuseppe Zummo from In4, Alessandro Piccinini, IES and R2M, and Luigi Filippo Borea from EcoPower. Okay. Thank you. Yeah, so we talked about carbon emission reduction. We talked about power usage effectiveness. So the first panel was very useful to address the construction and development of data centers. Perhaps now we enter more in the functioning of data center, and actually that's stage 7 of the RIBA design process that was mentioned before, so the moment when data centers are actually in the operative phase. I'm now stealing some data that was mentioned in other panels some months ago by the Osservatorio Data Center from Politecnico di Milano. The French Institute for International Relations says that the information and communication technologies sector today accounts for 9% of global energy consumption. And the growing energy demands that is due to cloud services and AI technologies, etc., has, of course, exacerbated this trend. In the future, these hyperscale data centers, also the very big ones, will gain shares amongst all kinds of data center, and AI will also account for around 20% of data centers' electricity demand by 2030. So we have to expect that if today, more or less, data from 2024 confirm that global energy consumption from data centers accounts for about 2%. By 2040, it is expected to reach 12%. So obviously, we need to deal with energy consumption, and we now have a good, I think, session trying to address how emerging technologies can combine sustainability, innovation, and operational advantages in data centers. So a discussion with technology providers. I will start with Giuseppe Zummo, who is telling us something very technical about two-phase cooling solutions to increase efficiency and reduce consumption.
Thank you, Chiara, for the introduction. Okay, so today I'm going to give you some information about a new cooling technology solution for data centers and how this new technology can improve the efficiency and reduce the energy consumption of data center. My name is Giuseppe Zummo. I'm CEO of In4. In4 is an Italian startup that are developing and commercializing this new technology. So let's start with some challenges in data center that we want to address. So one is related to the power density crisis, and that one is on the efficiency gap. So concerning the power density crisis, we have that the processor for AI, in particular GPUs, are reaching 1,000 watts and more, 1,200, 1,500, etc., per chip. This is connected with extreme miniaturization and generates very high thermal power densities or heat density that traditional cooling systems like air cooling or liquid cooling cannot handle very well. And the actual generation of this kind of processors are hitting the physical limits of these standard technologies or available technology on the market, like air cooling, as I mentioned, and liquid cooling. The other issue is the efficiency gap. So again, standard cooling technologies force data centers to make a sort of compromise between performance, energy efficiency, and sustainability in terms of QEA and water usage. And this kind of situation is not more sustainable for the future, especially for the future processor that are coming to the market. So there is a strong need of advanced new cooling technology, new cooling solutions for this kind of next generation infrastructure, AI infrastructure. This is not an option, but it's a strong necessity. Okay, so what is the solution that we propose to the market? It's called the two-phase cooling technology. So here there is an example. I don't want to bother you with the technical aspects of this technology, but just to give you an idea of what is the heat transfer mechanism of two-phase cooling system and why it is different from liquid cooling system, for example. So in two-phase cooling system, we have evaporation and condensation. And so heat generated by the processor lets evaporation on the heat exchanger. So the higher the thermal power, the higher the quantity of vapor. If we compare this with liquid cooling system, where the heat is removed by increase of temperature of the liquid medium, we have that this new cooling technology is more efficient than standard liquid cooling technology. So this means lower flow rate, and this is a critical parameter. This is very important parameter. And in general, a very high thermal power that it can be removed by processors. So what are the advantages that this technology can provide to the data center industry? So first of all, very high thermal power density to be removed. So it's possible to remove up to 100 watts per square centimeter and more, 120, 150. Maybe for you, these figures are not interesting, but 100 watts per square centimeter is, just to give you an idea, is in the lower range of fusion reactors components. So, of course, this is the lowest range. The highest range is maybe 5,000 per square centimeter watts. So it's completely different. But this just to give you an idea of the high values that we are reaching with the new GPUs. And again, for example, H100 NVIDIA GPU, famous for that is used for ChatGPT, is about 70 watts per square centimeter. So we are quite near this limit that I mentioned. Another advantage is that we use, it's possible to use a dielectric fluid that is, we don't use water. So dielectric fluid is a fluid that doesn't conduct electrical energy, electrical current. So even in the case of accidental leakage, you don't have destruction of electric and electronic components under tension with the tension applied. And another important advantage that I want to stress today is that with this technology, you can eliminate the external cooling infrastructure. We will see later, but just to anticipate, we can remove chillers and evaporative cooling towers. These two infrastructures are the main causes of the sustainability issues that the previous sessions indicate for the data center. So it's possible to remove chillers. This means that we can reduce the energy consumption for cooling, and evaporative cooling towers, so we can reduce or eliminate the water usage. And this is especially in summer seasons for the European countries, in particular for Spain, Italy, and Greece, but also in other parts of the world where the hot climate is very important. So, and so these are the main advantages of this technology. What is the origin of this technology? We didn't invent anything, actually. This technology has been developed in the last 60, 70 years for nuclear reactors, but of course in large dimension, large geometries. What has been done during the last 30 years of research around the world is to reduce the dimension of these systems down to the size of electronic components in order to cool electronic components. So these components in generally are related to high power electronics. Okay, so what is possible to do with this technology? So the PUE, the power UJ's effectiveness can be reduced from in the range between 1.5, 2.5 for a traditional cooling system. This depends on the technology used in the data center and the quality of the cooling system. It's possible to reduce this down to a theoretical limit of 1.05. Between 1.05 and 1.2. This range depends strongly on the configuration of the data center. Just to give you an idea, so for example, if you put the external heat exchanger called dry cooler is a system that that is not a chiller or doesn't use water. So you release the heat generated in the processor outside with this system. Then if you put this at 30 meters of distance from the data center, the PUE is about 1.07. So this is just to give you an idea of how is important the design and the configuration of the data center on this particular KPI. So with two-phase cooling system, it's possible to reduce this and in general to reduce the electricity than the standard of the standard cooling technologies down to between 30 and 50%. So the other important parameter is the water usage effectiveness. So it's possible to, as I told you, to reduce this to zero with two-phase cooling. We have here a comparison of this parameter with other technologies. I let you know that this comparison is not easy to do because it's not easy to calculate exactly what is the water consumption, because it's not only the water consumption of the data center itself, but in this calculation you have also to consider the water the water consumption for the generation of electrical power for the data center. So it's very complex calculation. In any case, in this case, it's possible to reduce down to zero because with this technology, it's possible to cool the GPUs and the CPUs with external temperatures of 45 Celsius degree. This is an important limit. Normally, with liquid cooling, you can cooling the data center with an external temperature about 35 Celsius degree. If this temperature is higher, then you need to use evaporative cooling towers, and these components are the components that consumes water. So evaporative means that water is used to reduce the external temperature of air down to from 45 Celsius degree down to 35 Celsius degree. And with liquid cooling, it's very difficult to increase this temperature for several technical reasons. One of these reasons is that you cannot increase the flow rate of liquid cooling system as much as you like in order to improve the efficiency of the system. So there is a certain technical limits over which it's not possible to go with this parameter. Okay, sorry for this long technical explanation, but this is to explain why this limit 45 is important. And today we are also working on developing a new patent in order to increase this limit up to 60 Celsius degree. Why? Because even when external temperature, ambient temperature is 35 Celsius degree, you can find that on the surface of the heat exchangers on the roof of the data center or outside the data center, during summer season, you can reach higher temperature, like 50 or 55 Celsius degree. So this is the reason why we are going to improve this, this value. But not only for this, but also for a European project where we are involved with other partners, and this project will be presented later. So, again, what are other advantages of two-phase cooling solutions? So it's possible to simplify the infrastructure of a data center. Here there is a very schematic representation of a data center with two racks in this case. And so you see that the heat is transported outside the data center and released to the ambient with the dry cooler. The dry cooler, as already explained, is a device that, without the using of water, can release heat outside, even in the ambient, even at higher temperature, like 45 or 50 Celsius degree. So with this system, it's possible to simplify the design of the data center by using fewer mechanical components, and as a consequence, you have lower maintenance overhead, or in the case of two-phase cooling system, actually you don't need maintenance, because the fluid is quite clean, and you don't have issues inside the flow channels or the piping system. Another interesting factor is you can reduce the installation cost. So, again, when you reduce the infrastructure complexity, you reduce the investment cost for a data center, and also the operative cost, in the sense that you don't have to spend energy for chillers or water for evaporative cooling towers for the data center. And again, also you can improve the reliability due to the fact that the fewer components, the better reliability of the system. Again, here there are an example of cold plates developed for the GPU and the CPU. In this case, with these two cold plates, it's possible to reach 1000 watts and more, and for both components. This is, again, as I told you, due to the more efficient heat transfer mechanism of the system, of the heat transfer mechanism. We also use aluminum as a material and not copper. This also decrease the cost and also the mass of the system. And it's also reduce the cost of manufacturing, because aluminum is much easier to work with. We also develop patented technology. We have some patents on the geometry and the surface treatment of the heat transfer of the microchannels. This is important because two-phase cooling needs some specific microgeometry of the channels of the evaporative surface. In the top right of the picture of the slide, you can see an example of what happened inside a typical heat exchanger that we call the evaporator, that is attached to a processor to be cooled. And you can see evaporation that occurs inside. These are the other components of the two-phase cooling system, and these components are quite standard. There is a CDU, so it's a coolant distribution unit, a manifold that distribute and collect the fluids in the servers. And yes, it's possible we develop these cold plates for this family of processors, Xeon, NVIDIA GPU H100 and GB200. And we expect to deliver our solution in January next year. So who we are? In4 is, as I told you, is a startup, an Italian startup. Actually, is a spin-off of Enea. Enea is one of the largest research centers in Italy. The co-founders are researchers of Enea, and we developed this technology in the last 20, 25 years for space applications with the European Space Agency project funded by European Space Agency. So at the beginning, we developed this technology for space, and so we perform several, let's say, parabolic flight and tested this technology in microgravity and hypergravity conditions. And a few years ago, we had the crazy idea to create this company, and with the idea to use this technology also for terrestrial applications. So we are in Rome, near Rome, in Formello, and also we have been incubated in the ESA Lazio Innova Incubator Center near Rome. So this is the team. At the moment, we are about 12 people, and in the future, we are rising funding round, and so we will increase this number of, the people. So thank you for your attention. And just I want to mention that In4 is the company, and sometimes you can see Eva Cooling. Eva Cooling is our trademark for our technology. So thank you.
Thank you so much. A very interesting journey into energy optimization. And also congratulations for this interesting company and the, bringing up the evidence that there is a transferability across technical domains. So really interdisciplinarity can help advance sustainability in the sector. And now Alessandro Piccinini will tell us instead something about the applications of digital twins to support decarbonization. Thanks.
Thank you for the introduction. So good afternoon, everyone. So before starting with the presentation of the R2M digital twin solution to support decarbonization processes, I just prepared a very quick introduction regarding the energy impact of data center in the next year. So currently, the data center are consuming around 96 terawatt-hour per year, and by 2035 is expecting an increasing of 140 terawatt-hour. This is a huge increasing, but since it's always difficult to understand these big numbers, I just prepared a comparison with the new EPBD4 challenge. So that is like one of the main arguments that R2M treats. And basically, the new EPBD gives some targets for residential and non-residential buildings. And for non-residential buildings, we have two targets, the main targets actually. One target is for the 2030, and the main scope is to renovate the 16% of the worst performing building. And the second target is 2030, where we need to renovate the 20% of the worst performing building. So here I prepared like a very quick raw calculus. And probably the consumption will be a bit tighter, but it's not the point of this presentation. But just to say that this reduction, if we bring this building from class G to class Z, so A4, this reduction in consumption will be around 2080 terawatt-hour. If we think to bring this building from class G to class C, the reduction can be around 140 terawatt-hour. So basically, the reduction due to the new APBD for the not residential building probably will be totally covered by the increasing in terms of consumption of the data center. So this part is just to point the importance of creating like a digital solution, digital twin, and provide innovative solution for increasing the efficiency of the of the data center, but not only the data center, but also the normal buildings. So for this reason, in R2M, we have this, let's say, digital approach for the digital twin solution. So basically, we work with 3 levels of detail. The first level of detail is the urban energy modeling, where the scope is to, let's say, identify which are the buildings that need more attention in terms of retrofit. Then the second level of detail is the detailed building energy modeling, where we analyze in depth the building and we create like a retrofit scenario focused on the building. And finally, this is like a new path, is the continuous commissioning and performance monitoring. And here the scope is to utilize the detailed model to detect anomalies in the real building. So to do monitoring, but not just monitoring, but also reuse the detailed energy modeling to assess and to do like fault detection and diagnosis in building and data centers. So at this scope, in order to present like our digital twin approach, I'm going to present a series of case studies, hoping that they can be interesting. So the first case study is a work that we did with EURAC and Senchim for the municipality of Padova, where the scope of R2M was to assess the energy needed for heating and cooling for the whole municipality of Padova. So what we did here was to utilize the ICD tool in order to model the whole municipality. And then, thanks to the tool, we were able to assess the heating and cooling demand of the municipality. With this heating and cooling demand, we created the district heating and cooling grid. And just to mention, from the grid, we were able also to recover from some of the vast heat from a data center. And thanks to the recovery of vast heat, we were able to have like a very good return of investment from the district heating and cooling grid. So here you can see some number. But what I would like to mention is the importance of this kind of analysis, so the urban level energy modeling, because as you can see from this slide, in EU, most of the data centers are located in the, let's say, the big cities, like the 34% of the data centers in UK are located in London. The 97% of the data centers in Dublin are located, in Ireland are located in Dublin. So it's very important to do this kind of urban level analysis to understand how much we can recover from this data center and how much we can give to the buildings in order to improve the efficiency of the data center, but also to improve the efficiency of the buildings that are near to the main city in Europe. So this is like another point of view with the model we did at urban level. What we can do is also, let's say, an APBD analysis in which we can underline which are the buildings at urban level that needs to be renovated under the new APBD. So then the second level of detail is the detailed building energy modeling. So in this case, the scope is not to model the whole municipality, the whole district, but is to model the single building. Here I'm presenting let's say a small data center, it's not a real data center, of the European Space Agency in Madrid, where we helped the design team to improve the efficiency of the building by providing innovative solution in the data center area. And thanks to this innovative solution, we were able to reduce the 32% of the consumption compared to the baseline building of the LEED, and we got the gold certification. So this was not just, the scope of this work was not just to take the plaque of LEED, but was to follow the design team in reaching the best energy efficiency for the building. Another case study this is from the IS team. So this was made again with ISB, that is the detailed energy modeling software. In this case, the scope was to study the ventilation system of the Central Bank of Oman data center. And here you can see that we utilized, in this case, the CFD analysis, and we did some detailed study of the ventilation in order to improve the ventilation system inside the data center. So the only problem right now of these models, so the detailed models in general, are that basically and usually after this kind of analysis, they are not used. They go in a bin. Okay. So the scope of these two platforms, so iScan IS Live, is to reuse this kind of model for doing like anomaly detection, fault detection and diagnosis, for monitoring. So what we do here is to use the platform IS Live, in which we can monitor all the performances of the data center. But what we can do also is to compare the performances of the data center with the digital twin that we made with ISB, so the digital twin made with the ISB software. And by the comparison between the real consumption and the simulated consumption, we can detect anomalies, we can simulate like energy efficiency scenario and things like that. So last thing, so here the slide is a bit crazy, but okay. Is this like new application that we are creating for giving our experience to everybody? So basically, we are creating this new application. It is like in a proof of concept phase. Basically, this application can be used by anyone that can put the information regarding the building. The scope is to have different archetypes, and one of the archetypes will be data center. We already did a proof of concept for the schools, and it worked well. I will present later the case study. But basically here, this application will be like a web application in which the user can insert some data regarding the building. Automatically, the application will, let's say, estimate the missing data regarding the building. And thanks to our experience in terms of energy modeling, we created like an algorithm that will be able to assign this building to an archetype and to an energy model. And thanks to this methodology, we will be able to estimate the result of efficiency scenario in different type of building. So here, just to present you a case study that we already tested some months ago. So basically, we utilized this technology for 100 schools on an Italian region. And we applied this methodology, and in a few weeks, we were able to estimate for each of the schools different KPI regarding the energy efficiency. So we estimated for each of the school different energy efficiency scenarios. And then we estimated also some economical KPIs, so like the cost of the retrofit, the return of investment of the retrofit, the payback period, the capex, and so on, with an average error compared to a standard simplified methodology of around 10%. So just to conclude, so if you are interested in this kind of products, tomorrow we are going to do like a short workshop in room 5, where I will present the ICD platform and the ISIM platform that are the two tools for the urban modeling. So if you're interested, I will be happy to present you the two tools. Thanks for the attention.
Thank you. Thank you so much also for being in time. So, great. So let's conclude this session with Filippo Luigi Borea telling us something more about optimizing energy flows.
Hi, thank you very much. I'm Filippo Borea. I'm the CEO of EcoPower. Just a couple of words on EcoPower. EcoPower, said in the cool way, it's a company that has been established more than 14 years ago, that is owned by an investment fund. The not so cool way to define EcoPower, it's a company of electricians. We are electricisti, nothing else. A bit skilled, but this is our background. What we're talking about today is a description of what is the origin and the base of one of the biggest problems for data center. As everybody before me told, data center has a big problem due to the energy consumption. But there is also another problem that is called energy quality, power quality. That is a problem that today is, let's say, as big as an ant, but tomorrow will be bigger than an elephant, due to many different reasons that I will try to show you now. Okay. So let's start about energy efficiency. What does energy efficiency mean? Energy efficiency means performing the same task using less energy. So when we talk, for example, about renewable energies like solar power, aeolic power, we are just talking about providing and having a different supplier of energy doing the same job. So we are not doing efficiency. We are just paying less the energy bought from a different provider that can be the sun or can be the wind. Efficiency means reducing the use of energy doing the same work. Second definition, power quality. When we talk about energy, we have to think that energy is very similar to water. They do things in the same difference. The only big difference between water and energy is that water, you can touch it. You can see water leaking on the floor, you can see leaking from the ceiling. When there is a leak of energy, you don't touch it, you don't feel it. So it's an invisible problem. So power quality means, refers to flow of electrical power support the proper operation, but the problems are connected to stable voltage, frequency, waveform, and distortion and interruptions. Interruption is one of the main topics of this speech. So I give you a cool picture. Oh no, it's the next one. Okay, so volta regulation and micro interruptions, also micro outages, are problems connected to power quality. And the result of this is cost increase. Due to the problems, companies, industries, data center, everybody has a huge increase of cost. Because of problems, most of these problems are not due to the, let's say, to the building, to the property, to, let's say, the company factory, are due to the grid. But why? That's a cool picture. It doesn't come, it comes. This cool picture can see stars in the sky in the space. Not at all. This is Spain on April the 28th of 2025. I'm sure everybody knew what happened on April 28 this year in Spain. There was a power struck that involved almost all Spain, Portugal, and part of France. That means that in less than 5 seconds, 15 gigawatts, so almost 60% of the energy distributed in Spain, suddenly in 5 seconds switched off. Try to imagine your company click in 5 seconds. your computers, undergrounds, all the plants, all the server, everything switched off in 5 seconds, and it lasted 10 hours. Just to give you an idea, this problem caused more than 1.6 billion euros damages in 10 hours. Why? Why this happened? First of all, I don't want to say that Italy has the same risk. Or, yes, we have the same risk, but for many different reasons, we are much more protected compared to Spain, because our grid is much more efficient and we have different provider and supplier of energy in different parts of Italy. So let's say under this point of view, we have a better position. But why there is such a big problem, such a huge problem connected to energy and power, quality energy? The instability of the grid. What does it mean? That there are some external components that are giving to the grid continuous shock, continuous changes that the grid is not always able to absorb. What is one of the causes of this problem? Renewables. So solar panels and aeolic, that are, of course, the two main renewables in Italy. Just to give you an idea, try to imagine that you are in the Sassuolo area, close to Modena, where there are all the ceramics industries. There are 10 ceramics industries in 10 square kilometers. Just to give you an idea, let's make an example. Each company has 1 megawatt of solar on the ceiling. Let's say. Suddenly, it comes a cloud. So all the energy that was internally provided by the company is suddenly stopped because of the cloud. So they have to take this energy from the grid. Let's make a comparison. You are at home having a shower. You are there having your shower. Everybody in your house opens all the taps. Of course, the pressure of the water is less because it's shared with all the other taps. But what happens if the cloud goes away? What happens is everybody closes the taps. The pressure of the water increases suddenly. The same happens with energy. Ceramics, sun, suddenly energy from the grid, suddenly again energy from the photovoltaic, the solar. The pressure, so the current, grows up. Try to imagine what happens to all your instruments, to all your lines with this shock. And this shock happens many different times during the day. So this is an example of Italy. This is an example, is an image, a chart about how renewables increases in the last 10 years. So quite a lot. But what is the result of this problem? Mainly two. The first one is Italy. The problem is Italy in terms of the shape of Italy and two main points of Italy. Let's say a situation that is not very flat. The sun in Italy is in the south. Everybody knows it. The wind is in the south. Of course, we have winds also in the north, but are different winds, are local winds, Bora, Pelair, things like this. In the south, we have winds from Africa, so Scirocco, Lecce, that are almost quite constant. So where are all the plants, the eolic plants and the solar plants in Italy? They are, of course, in the south. But where are consumption in Italy? Consumptions are in the north and in the center. So we produce energy in the south, but we use it in the north. So what's the first problem? A transportation problem. You have to move a lot of energy from the south to the north. You have to move a lot of water from the south to the north. If you want to move water, you have two alternatives. Or you make bigger pipes, or you increase the pressure. If you have to move energy, or you make bigger cables, or you increase the tension. Just try to imagine under an economical point of view if it's more expensive to change all the pipes or to increase the pressure. Second, supply instability. As we said before, the cloud, the wind, sun, we have sun, of course, only during the day. Wind is not always stable. So there is also a problem of supplying, of continuity of supplying of this energy for companies. What is Italy doing? In Italy, we have Terna. Terna is the grid operator in Italy. That I can say Italy is much, much more advanced under this point of view than many other countries in Europe, included, of course, Spain, but also France, Europe, and UK. It's completely another level. Terna is deciding to invest 23 billions in the next 10 years. Who you think is going to pay these 23 billions? When people say, oh yeah, energy now it's very expensive, it will be low in the future, I'm not so sure about it. How they will invest it? Exactly in the points that we just discussed. So increasing the cables, also connecting in a better way the islands, Sardinia and Sicily at the beginning, but also the connection with the renewables. The grid must understand and must prevent what the renewables will do based on the, let's say, the forecast. Of course, AI is helping a lot on this. But this investment will keep the problems of instability and transportation, of increasing of the tension and micro outages. So what are the solutions? I'm not going into technical aspects because it's not the right place to do it. But the consequences are this one. So the increase of costs for any company. Cost, it's not only saying I'm increasing the cost, I'm paying more the energy, but I'm paying to solve these problems. I'm paying to protect my company from these problems. The first one is the voltage optimization. Very quickly, the grid gives you a theoretical 400 volts in low tension, of course, electricity, power, sorry. But must think, what do you do if you switch on all the plants, everything in your company? You must be ready to have enough tension to make everything working. If you open all the taps in your flat, you must have this enough pressure to use all the taps. 3 showers, your wife, your son, whatever. All this extra tension becomes heat, becomes something that you don't feel, you don't use it, you throw it away, it's transformed in effect of Joule. So all this energy that is thrown away, it's paid by the consumer. So there is a technology that's called the voltage optimizers that can give a reduction in terms of electricity consumption between 4 and 6%. Just somehow filtering, of course, I'm making it very, very easy, filtering and keeping all the extra tension inside and using it. So you do the same work using less energy, what we called at the beginning energy efficiency. This is the solution for voltage. Micro outages. Micro outages are interruptions, usually less than 1 second. But you can say, oh, it's just the light flickering or it's something like this. But especially for modern plants, it's a huge problem. Because modern plants have a protective system that if there is a leak of energy, they say, oh no, something's going wrong. I stop everything before everything is gone. That means that you have to stop the plant. This problem can cause incredible amount of money and troubles. I decided to give you an example of a company. I chose a company of a completely different field. There is another example of a company that make a microprocessor close to Agrate, but I do want to talk about it. But I can tell you that every micro interruption costs them 300,000 euros. This company makes tomatoes. They work tomatoes. They make salsa. They are specialized in tomato processing. They used to have more than 5 micro outages per day. That means that every time there is a production downtime, they have to throw all the tomatoes, already boiled, chopped, sterilized, away, because the process of sterilization is gone. So the product is not more safe. It's not safe anymore. Try to imagine that all what you have done, all your job is thrown away because of micro outages that they say 0.5 milliseconds. For them, it was a problem of thousands and thousands and thousands of euros every day. So they were considering to move completely the plant to another place. Because of course you can comply to the supplier. Of course you can say, give me back the money, whatever. But you have to provide, if you have to provide the sauce to Barilla or to Chile or whatever, and you don't provide the product, it's not a term of money, it's much more. The solution to this kind of problems is micro outages compensator. Without going deep inside this kind of device, what does it do? It works giving an energy that, let's say, make flat the outages, and it stays all the time like waiting, like hidden. When there is a problem, it comes out, say, okay, you need energy for, say, 0.3 seconds. Here is the energy. And this gives the continuity. This gives the opportunity to keep the work without problems. So, final consideration. The problem is now, as I said, as big as an ant, but will be bigger and bigger in the future. And the problem will be very cost effective, very deeply involve all the investment, the ROI, and whatever, or the business plan of the companies. The good news is that there are the solutions. The market will develop more solutions in the future because we will have more problems. This technology has been on the market for 20 years, 15 years. The problems are now because the cost of energy is huge, because the consumption of energy is huge, and because the problems are growing years by year. Thank you very much. Bye.
Fantastic. Thank you so much for helping us understand how technological progress can help us tackle some of the challenges related to data centers implementation and development. We're stopping now for a little break. We'll be back in 15 minutes, and we'll close up with a session dedicated to research and development. So thank you so much, and have a good coffee time. We can start again. Thanks for joining this last session of the afternoon before the closing. We are here to discuss in this block some research and development initiatives, some especially key results from European projects. And in particular, we talked already about the environmental impact of data centers. Data centers consume, of course, enormous amounts of energy, of water, that is affecting also the national sustainability goals and are putting pressure on existing power grids. We heard about this several times already today. There are some initiatives also from the public authorities in different countries, Ireland, Germany, the Netherlands, Singapore, China, and so on, and the United States also, to introduce specific regulations and mitigate the environmental impact. We were also discussing before with some informal talks about edge data centers. So these smaller data centers that are located closer to the demand of energy, of data, of information that also consume less energy. And then another emerging approach is that of adopting recycling strategies for waste heat, and so reuse it to heat, for instance, homes and so on, or commercial space in the vicinities. Beyond these strategies, we have great research initiatives that are exploring additional strategies and that can show us in a moment some concrete and replicable solutions that can be applied. Also taking inspiration from contexts other than data centers, and we can, let's say, import in the data center world and domain to regulate energy efficiency and to go into the sustainability direction. So with us in this final session, we have Marcello Aprile from the iCool IT project, Politecnico di Milano. Then we have Yannick Krabben from the Moderator project, Attila Moritz from Heatwise, and Robert Birke from University of Turin. So I'll leave the stage to our first speaker, Marcello Aprile, talking about efficient thermal management of IT server rooms in tertiary buildings.
Okay, good evening. Thank you, Chiara, for the introduction. So my role here is to showcase some preliminary results of the high quality project. And then well, I will jump directly to what iCool IT is. Basically, we focus on small data centers, such as the one we have in universities, hospitals, so tertiary sector. And the main reason is that there are many of such data centers in the EU. We talk about, on average, 25 racks per small data center. But with the increase of power capacity of racks, even 25 can really turn into a huge demand of electricity. And therefore, the efficiency is a concern. And since they are linked to buildings, the opportunity to recover the waste heat into the building is clearly a possibility that has to be explored, and so far this is not common at all. So our goal is to develop solutions for this specific case. Of course, we start from small data centers, but we also aim to replicate what we develop in here into larger scale. And our innovative solutions are related to the, let's say, digital part, how we control the energy management inside data centers through the digital twin solutions, and also on the mechanical part, how we provide cooling, how we can provide cooling to data centers into a more efficient way. And yeah, these are the two main strategic goals of our project. the building digital twin, in which we cover not only the data center, but also the building together, and potentially the waste heat recovery system. And the methodology that we use to build this solution that I will explain later on briefly. And the second strategic goal is the development of a new cooling system that can be integrated into the rack and that can leverage on the heat produced by servers to produce some cooling that can be locally used, and in this way, providing a compact way to cool servers and at the same time cool the room and the other devices that normally are air-cooled into server rooms. And also this solution can, we will see, provide waste heat at temperatures which are of interest for integration into perhaps district heating networks, not just the building itself. And the interesting part of the project, besides the development of this solution, is that we want to validate them for real. So we have a demo system in Milan at Politecnico, and we will test the solution both in the laboratory and in a real scenario. And last but not least, what we are learning from the experience will be made public. So the aim is to provide engineering guidelines on these processes and contribute to standards and, of course, work on business models for replicability even in the larger scale, like large data centers. So I would like just to mention that in a digital twin solution, we have for sure a lot of modeling, and the digital twin is a framework, but there is no clear definition of what a digital twin must be. And let's say in our way, in our interpretation of this, it's very important to adopt not only the data-driven approach, where we collect data from the real world and we store them into a database that we can then reuse to fuel some surrogate models that are used to optimize the system. But at the same time, we would like to create a copy, a virtual copy, based on mathematical modeling of each component that we have in the server room and in the building itself, and in order to provide synthetic data in the end. So we would like to make the pairing of the two, the real and the synthetic, to have a simulation tool that really works and that we can use with more flexibility to test new solutions like new control solution, etc. The main limitation with the data-driven is that you cannot play too much with the system, especially if it is a critical mission system. You cannot really destroy the system trying to characterize characterizing the behavior. With synthetic data, you can do anything you can want, even planning to substitute part of the systems. What is not maybe evident in this is the huge effort that is necessary and the huge cost in creating the mathematical models for the energy operation of all the different parts that constitute a server room, the cooling plant, and the building itself. So we would like to do that in a manner that is standardized and that can be replicated and used in different simulation platforms with ease, basically. And this is one of the main objectives, not just a digital twin, but also doing the digital twin in a manner that makes sense for the future. Now I have to switch very quickly to the second strategic goal, that is the development of a new cooling system that is conceived to be integrated into a rack. And the idea here is to exploit the heat at relatively high temperatures generated by server to drive an absorption cycle so that we can generate some cooling that will be then used to cool other devices which are present in the rack and normally do not require direct cooling like liquid or two-phase cooling, because here the capacity density is not that high. So all in all, this is a compact machine that can be integrated into the rack. Here you see a first proof of concept of a machine, and that can provide power usage effectiveness of 1.1. And the main innovation is in the shape and in the way it is implemented in order to achieve that level of compactness. And then we should not forget the waste heat that in the end is produced, that in principle can be discharged to the environment through a cooling tower, but its temperature is quite interesting. It's enough high for heat pumping into district heating networks, even district heating, let's say the more traditional one that we have, for example, in Milan. So overall, this is a nice concept that can enhance even the social acceptance of data centers, because we maybe didn't stress enough the idea, but the point is that, yeah, we can work for decreasing the electricity consumption for the cooling part, but still we have a lot of electricity that in the end will be converted into heat, and it's paramount importance to use this heat in cities, and the obvious way is to connect to district heating networks. Okay, so coming to the demo, here is a slide representing what we are doing at Polimi. So we followed a renovation process of a data center, the one we have in the Bovisa campus. So this is going to be more efficient, and it will be controlled by this digital twin platform, and it will be connected. I mean, the waste heat will be reused to heat up one of the campus building. And the overall message is that even if at this stage we use, let's say, a trivial way to perform this integration, the waste heat recovery will just be based on taking heat from the cooling loop of a standard cooling plant. There is a business case which works quite well. So that's all for this short presentation. I leave you the contact details. And if you want to follow us on the internet, we are just halfway. And yeah, we hope to reach some interesting results to share with everyone. Thank you.
Thank you, Marcello. I hope I'll see some of the benefits of this project also in our campus, in the campus where I work, which is the other campus of Politecnico. But yeah, so now let's move on to Yannick Krabben, turning waste into value. Thank you.
Thank you so much. Yeah, my name is Yannick Krabben. I work at the Competence Center for Thermal Energy Storage in Lucerne, in Switzerland, at the Lucerne University of Applied Sciences and Arts. We focus there mainly on material development, so really thermal energy storage material development. And this is also the main contribution we actually have to the Moderator project, where my role is basically work package lead for the development of such materials. But first, I will go a little bit into a broader overview. As many, or as all of you know already from the sessions before the break, the heat demand, or let's say the energy required to operate data centers, is projected to be increasing quite a lot. And And as a comparison, I brought here a different metric that you already have seen in the morning. The sum of all of the energy that's required for the data centers is comparable to the energy consumption of whole countries. So it's a huge amount. And we're able now to reduce the POE quite a lot. And I think we will hear about more in the Heatwise project after, how to get to a POE close to 1. But in the end, all of the energy that you put into the system will be dissipated as heat at some point. And why not use that huge potential for something else? And this is exactly what the Moderator project is focusing on. So our focus is really this waste heat recovery system. And we are doing that actually in different steps. So our main focus at the beginning is the development of an immersion cooling system. So a system where the data racks are fully immersed in a dielectric fluid. We do their numerical system simulations, where the goal is really to get the dielectric fluid to the highest temperature as possible to then gain as much as possible for a secondary use. Then what we're also focusing on is actually the development of a storage unit to kind of bridge this intermittent availability between the energy provider, so the immersion cooling unit, and the secondary use. Within the project, so what are we really optimizing in the project? So first, as said before, we're looking at this immersion cooling unit to really reach the highest temperature as possible. We developed now three phase change materials that will be used to take the heat from the immersion cooling unit, store it, and then make it available for a secondary use that we'll look into a little bit deeper after. And the last thing is actually this highly efficient multi-layered insulation material, where there's also a circularity aspect. So we look into insulation materials that are produced from waste, actually, namely, for example, expanded glass spheres from PV panels and so on. Then one of our main goals that we're actually tackling is to have a certain amount of scalability. So the system should be really modular. The immersion cooling unit that we are designing is 40 kilowatts. And also the storage unit is kind of dimensioned to fit this 40 kilowatts. So in the end, from these 40 kilowatts, we can scale actually the system to any size that we want. And this is really one of the main focuses of the project. Then what we're right now working on a lot is looking into different case studies. So not only have the supply side, but also check geographically where should a data center be placed, a new one, dimensioning the storage system, of course, and then what applications we can then deliver the heat to. And of course, classic is are shown here. So office building and residential buildings. Then, for example, low temperature industry use, or we have also already looked into agriculture systems. So this just shows another possibility actually. So we are, as said, we're currently looking at different industrial sectors. We even already looked into different fish farms, for example, where you could use the heat. We have a case study in Norway because there you need a lot of low temperature heat to keep just to keep the water temperature at a certain level. Then of course greenhouses are always a topic, and just general investigation into where we can apply or we can reuse the heat that is stored, and then looking at different case studies. Then just quickly into the consortia. We are actually 11 industry partners in this project. We're all distributed all around Europe. With the first pilot that we're building in Greece, we are working there together with Synapsicon, Synopsicon. So they have already some data centers in use, and we'll apply our system design to a real case there. Then, for example, we have partners in, that's for example Syntef. They do the whole simulation part. So they do fluid simulation, how to really reach temperatures within the immersion cooling unit. Gerosen and Opholite are working on the insulation material. We at HSLU, together with COA Thermal Solutions, are working on the material development, where we also have now a pilot plant already in operation in a district, in a building district actually, that's providing heat for domestic hot water and floor heating for these buildings there. Then we have Highside Tech. It's actually, they are developing the whole system integration, so the interaction between each of the components, and yeah, in quite a strong representation in Greece. Yeah, that's already it on the Moderate project. Just a really brief introduction. Here are our socials, so it would be nice if you could follow us, and if you have any questions, I will be around now. Thank you.
Thank you, Yannick, for showing us these examples of heat recovery. Let's move on with Attila and some thermal connection of data centers and buildings. Thanks.
Thank you. Good afternoon to everyone. My name is Attila Moroc. My name is Attila Moroc. I'm the project coordinator of the HeatWise project. I'm coming from Hungary, from H1 Systems, which is Hungary's leading data center designer, build and operator company. We are an integrator. Yeah, the whole idea of the HeatWise project came from us, and we are always looking for new solutions. So I'm very happy to have here colleagues who are showing us in what direction they are developing the solutions. But what is our solution? Well, that is our project about. So we are going to connect data centers and buildings thermally. So, you know, data centers, they are producing heat as a byproduct that has to be rejected, and buildings are needing all year long heat. And for domestic heat, hot water, for heating, whatsoever. Okay, I thought I was too loud. Good. And we have 3 key indicators. PUE, you heard already what is PUE about. This is one of the most important, however, often challenged indicator of the data center industry. ERF, energy reuse factor, and primary energy saving. We said, what does it mean? These 3 key objectives. This is world class. You've seen here the previous moderator, 1.1. It is already excellent. Now the average is 1.618 in Europe, but there are still data centers which have PUE too. Okay. ERF 95 means we are capturing almost all the heat, what is generated. And of course, P is 20% means a massive CO2 reduction. And before going further, I just would like to call you here to convert yourself, if you are engineers, into businessmen. Okay, what is the meaning from business perspective of the PUE? Okay? So 1 is describing the energy consumption, so the energy cost of the IP. And after the dot is coming what is related to cooling and all kind of auxiliary energy consumers, electricity consumers. So when we are talking usually about efficiency of the data centers, we are talking about the figures after the dot. So dot 6, okay, and now dot 0.5. When we are talking about heat recovery and this heat reuse, then we are also talking about the first, about the 1. So practically 100%, I know it is maybe too much, 98% of the electricity is converted into heat. So we are talking about both of this figure. So let's see further challenges. In the previous session, there was already a lot of discussion about that. I don't want to spend time here. Latency, energy increase, EPBD, all kind of cost and asset value issues with the buildings, which are determining how these entities are operated. Both critical infrastructure, the data centers, they have to work 24/7, and the buildings, providing shelter and comfort for equipment, for people. So these are two entities which are forced to live together. At least this is the idea of the research, and this is the idea of EPBD and EDD. But what is the problem? The problem is the cooling of the data centers and how it is happening. The mainstream is 95% of the data centers are air-cooled. Air is a very bad energy transfer means. So practically, how the currently is done, 18, 25 degree, maybe 30 degree of cold air is blown onto the servers, and what comes out is around 25, 35 degrees. And when you look at the building side, they are far from this range. Yeah? So especially if you are talking about not modern building with low temperature heating, these temperature ranges is not really good. There is one more problem. Yeah, how we are setting these temperatures, whether we are giving the right amount of cold. And no, we don't. Yeah, sometimes the CPUs are overheated. There is a delay in provision of cold. So then thermal throttling is happening. What means thermal throttling? You put a lot of capex in your IT, and it is not working. Yeah? So often, the utilization rate, there was a KPI in the previous session, utilization rate, maybe 60%. That's too low. Your money is not working. So at the end of the day, practically you are wasting your money and wasting the energy that you produced, and it is also going into the air, into the environment, practically like litter. And they thought we can do it better. Yeah, we should not think of the current adjustment of the current way of cooling, focusing on the air temperature, because this is what the standards are saying, ASHRAE. It's telling to you what the humidity, what the airflow, what the temperature should be. If that is fine, that's fine. It's not like that. Yeah. So we are focusing on the components. We want to know whether they feel good. We want to know what is their temperature. There is an optimum temperature and a maximum temperature where they can work. Yeah? 70 degrees, 80, 90 degrees. So if we know that, what is their temperature, we know how much cooling to provide. So we provide air, and we provide liquid cooling. The electric, you remember from the previous session what it means? No water, absolutely harmless. Phase changing, okay? So the latent energy is also exploited. And we are giving to the right component. So we are giving liquid to the CPU and the GPU, and the rest gets air-cooled. So in this way, we can achieve much higher temperature levels, but are already useful for the vast majority of the buildings. Key here, as I mentioned already, data. Data in all stages of the cooling system. At the production side, where it is absolutely needed, the consumption, and at the building. So everything is turning around data. And then if we implement this solution, we have pretty impressive proposal. We would like, this is the research about, we believe we can achieve 95% of IT utilization, a stable and on-demand temperature, even reaching 65 degree, liquid to liquid, okay, which means also in turn impressive business advantages in CapEx and OpEx. So we believe we can achieve lower CapEx, lower OpEx, as overall less TCO, and we can fit in one rack something like 100 kilowatt of IT. And so the current is around 5, 8, 12. So it is a big jump. We are developing tools that help reporting, automatic reporting, and of course, decarbonization. We are implementing this solution at 2 out of the 5 pilots in Switzerland, at EMPA, and at RISE in Sweden. We are half time, still 1.5 years to go. And just quickly, let's go to the technical solution. Yeah, so we have several tools which we are developing. We have novelties in analytics and planning, looking at the building, what is the potential of waste heat, then actually the data center and business case development is coming. So analytics. There is a new methodology that we developed, and new KPIs, how to assess the potential of buildings, how much waste heat they are able to absorb. Okay? We have some recommendations, very simple. Find the low temperature systems in your building and connect your data center to them. We developed also a metering strategy. And if you want to learn more about this, I encourage you to participate in our November training held online by AAU University. Okay, planning CFD, we developed an open source based CFD tool. Before we would touch anything, any investment, we simulate what will be the effect of the investments on the various KPIs. I'm not going to tell to you all, but practically we are able to simulate on rack level, on server level, and cold plate level. And it is possible, according to our simulations, to achieve with the small edge data centers a 10-75% efficiency without yet implementing our core solution, which is coming now. So this is the core of our solution. So how do we get out the 65 degrees? It is done with on-chip direct cooling. Here, okay. This is phase changing. So there is a cold, how much? 65-degree cold is converted into 70-degree hot, which is given out by the HRU to the building. There is another part, which is the air-cooled part. Everything is in a closed rack, in a closed cabinet, supported with zonal cooling, air cooling. So we have an orchestration tool, and with this orchestration tool and with the MOTA algorithm, which is the maximization of the waste heat output, we are able to increase the waste heat output by demand. Okay, so depending where we orchestrate within the rack, we are able to achieve higher temperatures or higher heat output, or if needed, less. Okay, one more thing. So we estimate, according to our wind tunnel tests, now we are starting to build our pilots. According to wind tunnel tests, approximately 70% of the heat will be captured by the liquid cooled and 30% by the air cooled. And I think I have to stop now because I'm way beyond the time. Thank you for your attention. I'm really ready to meet you after this session or tomorrow and answer all your questions. Follow us on LinkedIn and participate on our events. Thank you.
Thank you so much. It's really interesting to see how many of these projects are actually connected and recall each other. So let's move on to the last presenter for today, Attila Moroz. Please, the floor is yours.
Yeah. Hi, hello.
Oh, sorry.
No.
I'm now cooked, so this is not, yeah, please. I got confused. Robert Birke, exactly. I was not matching the faces. So please, the floor is yours.
No problem. Okay, hi, thank you. So I'm Robert Birke from the University of Turin, and I'm here actually to present the project Diamond. Diamond is kind of a sister project to the first project which has been presented. So there are some things which now you should be already familiar with. But basically, so Diamond is dynamically managed self-cooling HPC data centers. We started in 10 partners a bit more than 1 year ago. And then actually we had a successful hop on. So now we are actually 11 partners distributed into 5 countries. So what is Diamond about? So the goal, we have three goals. The first one is
to develop further two cooling, so basically to develop two cooling prototypes. The first one we have already seen a little bit in the previous presentations is about absorber cooling. Here we really try to improve the technology. And the second one is to do two-phase cooling. And the main thing is to actually combine these two cooling technologies to cool better the data center. Then naturally, if you have new technologies, you also want to control them better. So the second goal we have is actually controlling this hardware with a more integrated management system, which is able to talk on one side with the cooling side and on the other side directly with the workload. So here we are actually going to integrate some workload management system, which is able also to modulate the energy consumption of the servers based on the workload with the cooling system. And then everything is nice, and if it's on paper, but then maybe you have to put it in practice and you want to validate it. So we actually have two test beds. One is at BSC, Barcelona Supercomputer Center, and one is actually at our university in Turin. So let's go a little bit more into detail. So the first core concept is that we want to design new absorption chillers. Here the main two challenges is, the first one is to find better materials so that we can actually lower the temperature at which this absorption chiller work. And the other one is to actually design better heat exchanger to actually make the heat exchange more efficient. And this we do it with actually 3D printed structures, as we will see later on. The second core concept is this two-phase cooling, where we really want to integrate the two cooling technologies. Here, the main challenge is to make the temperatures at which these systems operate compatible between them. So I'm not going too much detail into cooling, in the two-phase cooling system. There was already the presentation of Inquattro on this, which went into great details. So just a short presentation of the test beds. We actually have two, as mentioned before. Here, the key point of having these two is that one is the scale. So we have a small data center, which is hosted by us. It's designed for 250 kilowatt. And then we have a large multi-megawatt data center, or better, actually a supercomputer, which is the Mare Nostrum at the Barcelona Supercomputing Center. So the real difference between applying these two technologies at these two different test beds is that they are really different in the terms of scale, which they have, and also which means also the different technologies which are employed. For example, the first one is air-based, the second one is liquid cooling based. So we have to integrate these new cooling technologies also with the existing cooling to bring out the heat at some point from the building. Okay, so the challenges we are trying to address is that, first of all, we want to reduce the costs by reducing the power, the energy consumed by the cooling, as it's not just nice for the environment, but it's also nice for your wallet. So the less energy we consume, the less we have to pay. This is done because we want to increase the operational efficiency. And naturally, want to do this by avoiding any harmful refrigerants. So we are doing, there's a lot of material science in this project, which both at the level of the two-phase cooling and at the level of absorption cooling. Okay. Then the pillars on which the Diamond project is that we develop the cooling system, then we integrate this cooling system with this management software, and we actually then validate it. And In parallel, we are also participating in this AEC portfolio activities, which actually all the projects which have been funded in this Pathfinder call are part of. So we are also collaborating with other projects to see how we can actually kind of pinpoint ideas. Even if we are just about over 1 month, okay, we are roughly 15 months over in the project. We actually have already some key exploitable results which are finished, which is very nice. So the first one is actually, as I said, mentioned before, this 3D printed heat exchanger, which has a very particular structure, which kinds of increases the efficiency of the heat exchange. Okay. Then we have this new condenser, which again is an improved version, so that we can actually improve the heat transfer. Okay. Then we also have this integrated design between the lower temperature to then actually to kind of recycle the energy extracted, the heat extracted by the two-phase cooling and transform it into this into this cool air or cool liquid, with which we can either, similar to the high cool project, either cool the room itself, or maybe some other components which are less demanding or has lower heat densities. Then we are also working on actually, because before, as said my previous speaker, if you want to invest, you want maybe to play around, you want to simulate how much you can gain and so on. So we are also working on creating digital twins of these two data centers, so that we can actually test, let's say, design decisions before actually they would be implemented. This is ongoing. And then, as I said before, we have this management software, which actually can talk directly with the workload manager and directly with the energy control systems, which nowadays are inside all the servers, to actually modulate the energy consumption, also based on the requirements of the workload. And it has been now extended with an interface to be able to talk with the cooling systems in a data center. So as of now, there's no yet new control, but we already put in place at least the fact that the two can communicate. Then, as a last key exploitable result, we have the SimBots, which are these small mathematical models which can model the behavior of specific parts of the data center. And this is, again, then we will want to couple these with our digital twins to then be able to actually make more precise predictions. Okay, so basically, as of now, most of the physical components have been almost done. We plan to actually finish them by the end of the year. Then, in parallel, we are doing the virtual testing of these components. And then, let's say the last part of the project will be actually about validating these technologies in the real world, in the real case, so by deploying them in the two different test beds. And yeah, and we will continue our collaboration with the clean and efficient cooling projects from the AEC portfolio. Thank you.
Thank you so much, Robert, and thanks to all of you for showing us these applications that are not only about the research, but really are actually showing how some research is actually generating innovations that can be soon taken into the market and applied in real life. If you want maybe to leave the stage, we just have now some closing remarks. Alessandro Viviani from TIA Group. Thanks for being here, and perhaps you can wrap up this session by showing us some of the future scenarios.
Yeah, thank you, everybody. Thank you for the invitation. Let me start saying that I'm in trouble twice. First, because I'm the last one before the end of this day, and the second, because I arrived just after some of a very deep technical detailed presentation. And what I will show you, let me say, is a bit more higher level. And but my job is to provide to policymaker, to management, a big picture around what is going on the data center environment. Let me just a few words regarding Ambrosetti, who we are. We are a consultancy firm, a think tank located just on the other side of the street here in Milano. We have 350 colleagues. We work on several domains, on the digital, on the energy, on the real estate domains. And to what concerns data center, we have seen the needs to start up a platform, a discussion platform involving some of the leading companies that are working on data center in Italy, just to create a cross-industry platform for discussion. We see that the industry of data center is too much conservatives. There are very lack of capacity of creating bridges between the digital environment, the digital infrastructure environment, the energy environment, and the real estate. And this is be the topics of my presentation today. I will go through some presentation here. So what is going on? This is, let me say, my first slides. So big step for Italian region, Milano. As Italian, I just asked myself why we arrive as almost the last one among the largest country in Europe. On the top left side, top right side of this picture, you see what is currently Virginia. As you can see, a larger environment for data centers. But where are we now? This, everything also in Italy is happening in a scenario in which, despite a very steep increase of data center capacity, on the other side, we see that we have never enough of data center. The orange line is the spare capacity within data center. So the question is, where are we going currently, and especially in Europe and in Italy currently? So first question is, shall we look at a scenario like the one in the US? Probably the answer is no. Probably in Europe now we are following different pattern of demands that especially are not similar to the ones that are facing by US, and probably with a little bit of shadow by China. If we look at the 20 large language model developers worldwide, only one has been trained in Europe. And of course, as you probably know better than me, this is one of the main driver of demand for new infrastructure in data center. The second question is whether we will see a development of further regions in Italy, or whether we will see the development of a more spread development of data center infrastructure in Italy. So to what concern now a picture of Italy, we see a little bit of development in Latium area, in the area of Rome. But what concern other part of Italy, probably it is something that it has still to come. Probably we will have an upside in the coming years that will be presented by the application of security directive, the NIS2 in particular. We need to take into account that currently in Italy, something ranging between the 50 and the 70% of the data, depending on the different sector, is still within the premises. So probably there will be the need to develop a new hybrid infrastructure that will take into account both on-premises and centralized infrastructure, with what we call edge data center rising in importance, but it's still something that has to be demonstrated. Sometimes in Italy, we heard about the potential role of Southern Italy to develop a second region. It is something that needs to be demonstrated. I have no evidence of such development currently. Another potential upside, there are the different kind of artificial intelligence that are currently being developed, especially the agentic artificial intelligence. As you probably know better than me, agentic artificial intelligence is a specific kind of artificial intelligence that need proprietary data from the enterprises to be trained. So it is something that will require an increased share of data center at the edge with lower latency, and especially sometimes outside the perimeter of the hyperscalers. So, of course, this will be not only a matter of performance, or not only a matter of latency, but also a matter of how the different companies will start developing their own data infrastructure, especially the largest one. So when we arrive to the scenario, we have seen a different kind of scenario around. I can provide you certainty that for the time being, nor the companies, nor the government, the policymaker have a clue of what will be the scenario. We provided this that has been developing with a very careful analysis of the demand and the capacity of attracting investment in Italy. So by 2040, we expect a capacity in Italy of 4 gigawatt of data center in an intermediate scenario. Of course, there is a big fork between the different data, that it will be not due to the lack of demand of digital service, but on the capacity of Italy to attract investment. So based on this, how we can create a sustainable and scalable model, I here provide a picture on the background, which is the metaphor of rice on the chess dashboard. I think we are not far from this. I think that whether it will be an exponential or a booming increase, we still don't know. I think that we need to be prepared right now to manage what will be the impacts of a data center in the coming future. And why what was just said by the panelists that arrived just before me is really, really important, because we need to be ready right now to manage what will be the impact on different domains, especially the energy, but not only the resources. We spoke about a lot of water and circularity, but also the impact of on the territories and the capacity to create a valuable impact on those territories. Just few words around this. Energy, we saw a lot of application later on, before, regarding the impact of different kind of fuel. We just made a very simple what if analysis. What could be in Italy if we are not able to decrease the POE by the 1.5, 1.6, that is the current average, to 1.2. We will require more renewable energy equal to 60,000 football pitches. So a lot of spaces that will be dedicated only to a kind of waste of energy. And what it comes to my mind now is why advanced cooling technologies like the liquid cooling or all the others that you already provided us more insight is no longer an option. We need to go ahead with this kind of technology. And here is our policy recommendation. Best practice need to be proactively promoted by the policy. If a data center project demonstrates to maximize efficiency, to minimize the use of land infrastructure, energy infrastructure, if they deliver tangible benefits to the communities, so it has to be granted access to a streamlining permitting process. We need to have policies that are able to understand the best practice in the development of data center, and we need to have policies that are able to provide incentives, not money incentives, but time incentives for the development of data center within the permitting process. Of course, this is a matter of capacity of creating knowledge between the policymaker and between the people within the public administration that are invited to evaluate different process. I just nominated energy. I think, I'm sure, is the most important issue to what concerns the data center. I also asked before why in Italy they arrived so late with the development of data center, and I will provide you a few hints. But let me say, we just have been spoken about how to decrease the PUE 1.5, 1.2, 1.05. But the real matter now to who is entitled to develop a new data center is how to feed, not how to cool. It's how to feed the data center with the required energy. Is an analysis that we have run regarding the the time to power in different countries of Europe. As you can see, now countries like Ireland, UK, part of Germany are currently, let me say, out of the game. France, Spain, and the rest of Germany have some criticalities. And then now it's arrived at the moment of Italy and the Nordics, because we can grant a lower time to power. But my question is, how long this will last? Currently, we are leveraging old power lines dedicated to former industrial sites, and probably this will be, let me say, used in the coming few years. And then we need to start thinking of what will be later in order to allow the capacity to invest in Italy. We are used to heard from the developers of data center, follow the cable, so follow the data connection, but now the mantra is follow the power. The main issue of the data center developer is to have a safe, reliable, and timely energy connection. And in this, what I can say for sure is that the current model probably is the model that is most difficult to be pursued in the future. So when I say the current model is 100% network electricity, continuous availability with 24/7 renewable energy, diesel backup. And the wide evidence of why this is the most difficult are on newspapers. You can every day look on the Financial Times problems in developing data center in different parts of Europe. That's why we, together with our partners, we are developing a new, what we call data and energy hub, which is a concept in which the capacity to integrate different energy technology within the perimeter of a data center, of course, with the collaboration of different entities, is able to transform data center from being an obstacle, a problem for the network, in being a grid asset, able to provide capacity, maybe provide ancillary service to the external network. We are currently running some simulation. I just provide you a few hints regarding some of the benefits. The first one is reduction of the cost of energy. For a 100 megawatt data center, we calculate a minus 7.6% of energy cost and plus 7.9 million euro EBIT, just integrated some batteries. And when it comes to the capacity to integrate on-site generation, we calculate minus 82% in connection required. That means less and less time in waiting for Terna that provide you the connection. So I would like to conclude with a topic regarding where are we in terms of maturity of our value chain, how much are we able to capture value from this development currently in Italy. The answer is that our capacity is quite poor because our value chain in Italy and especially in Europe is not prepared to face this increase of potential demand. Here is our model of value chain. As you can see, it's really, really simple. But to develop a data center, we need the capital, we need the developers, we need the real estate that, as we will see, now are completely out of the game. We need data center operator, and then we need the data center users, so the ones that provide digital services on the market. And we see in these 5 main criticalities. The first one relies to the completely absence of dedicated finance for data center in Europe, and the completely absence of a proactive role of real estate within the European data center environment. This is quite completely different from what is going on in the US or what is going on also in UK, where data centers are among the first investment choice for the real estates. What we see now in Europe is that the data center is not among the priorities for investment. We are just above the sub-storage investment, so very few, very low interest from the investors. Why? But mainly because we have an environment that is not proactively evolving in order to allow investment and provide certainty to the investor. We have a regulation that is too fragmented. We have a very low understanding of the demand. As we see in the US, it is driven by the development of larger language model. In Europe, we have not this kind of demand that is rising. There is a lack of liquidity and transparency regarding this. Most of the data centers have been developed by hyperscaler. We have no more liquid demand for different kind of infrastructure. We have the problem of energy. We have the problem also of local context. The second criticalities is the lack of intersection between the demand and the provider of services. The one on the right doesn't know what the one on the left can provide them, and the one on the left doesn't know what are required by the one on the left side. So real estate and capital provider have no clue on how to make money on the data center market, at least in Europe. The third criticalities is the developing. I call this as a for West. Since I started the community with Microsoft, AWS, and the other partners, I receive at least 10 proposals for sites a week on LinkedIn, but no one of these sites is suitable for data center because it's our site that come from developers that are used to work in the renewable energy, and the process to qualify sites for data center is completely different. We need to develop a site qualification process that is more suitable to provide de-risking to the developers. I just jump here some evidence to arrive to the conclusion. I have just the last criticalities, which are talents. Hopefully, there are several universities that are now working in order to promote the technical people that are able to work on data centers. But we need also to look on the people that are able to work, let me say, blue collar, that are able to work on the plans related to the data center. I just concluded, calling you to have a look on our website and the activities that we are running currently on the data center community of Ambrosetti. Thank you.
Great. Thank you so much for this provocative final remarks. So we went from the macro level at the beginning of this afternoon to explore the micro level of all these systems that are hosted within data centers and allow their functioning. And then we zoomed out again to this macro level to consider all the systems that actually are outside of data centers and that enable their development. Thank you so much for staying with us, and I hope maybe we can share some questions and answers outside before going away and going to the dinner. Thank you so much.